Welcome back to Geometry Chapter 4. Try that again. Chapter 12, Section 4. My brain went on to. We're almost done in this book. Chapter 12 is the last one. Excuse me. And we're at 4 of 7. So we're really close. I'm about to get to wear my party hat that we're at the end of the book. Alright, so we're going to talk about the volume of prisms and cylinders. Remember, that's the prism. The oatmeal can is the cylinder, which I have the oatmeal box up here. But I think one of my boys decided to eat oatmeal for breakfast and took it back down to the kitchen. Alright, so some of this you should already know. So before we talked about area, and like with area of a piece of paper, it's length times width. But if you say volume, then it's 3 dimension. You're going from a flat surface to a 3-dimensional thing that you could fill up, and filling it up is the volume. And it's not just length times width, it's length times width times height, or whatever you want to call the 3 dimensions, x, y, and z. Whatever the 3 dimensions are, you multiply them together, and your units are no longer squared, they're cubed, they're to the 3rd power. So like if you're buying material, you can buy it in square yards. But if you're filling a tank, it would be cubic, a cubic unit, like cubic meters. And then of course there's a relationship between cubic centimeters and milliliters, that 1 cubic centimeter equals 1 milliliter. And that's why in the hospital they say, give me 4 cc stat. They say cc for cubic centimeter instead of calling it milliliters like we do in chemistry class. Alright, so you should know this one. Volume of a regular rectangular shape like a fish tank is length times width times height, by tradition written in cursive or italicized if you're printing it. The volume of a cube, where all the sides are the same, is length times width times height, which is side times side times side because they're all the same, or side cubed. Now if you forget that, just do length times width times height. Multiply it times itself 3 times, you'll get the answer, I promise. If 2 of these shapes, 2 polyhedra, are congruent, they will have the same volume. That makes sense. The total volume of something is the sum of its parts. You can think of a swimming pool. You got the volume of the deep end and you got the volume of the shallow end. The volume of the pool is all of it added together, right? Okay, so here's a problem. I have like a fish tank, and it's 5 units this way, 3 this way, and 4 that way. We multiply them together and it's 60 cubic units. 60 units cubed is how you say it. Normally if it's to the 3rd power we say cubed because we're the cool kids. Alright, if 2 solids have the same height and the same cross-sectional area at each point, they have the same volume. So imagine I have 2 cubes here, and I measure them, I see they have the same height, and then I take a saw and go and I take little samples all along both of them, and I compare them, and every place where I test it, it's the same area, then it would have the same volume. Another one is the volume of a prism, like this, is the area of the base times the height. So like this, how I'm going to do is I'm going to get the area of that triangle, then multiply it times the height. And the volume of a cylinder is actually the same formula, the base times the height. But if it's a cylinder, the base is a circle, so you could do pi r squared times the height, like that. So I think these are real easy when you take the test on this. I'll let you have a cheat sheet formula card. I don't make you memorize them. So you just figure out your knowns and unknowns, sing substitute into the formula, and get the answer using your calculator. Not bad at all. Okay, so let's do this one. What is the volume of this prism? Well, it's base times height. And the base is a triangle that is 3 on one side, 4 on the other. It's a right triangle. So I can use 3 for the base and 4 for the height. So the area of that triangle is 1/2 base times height, 1/2 3 times 4, which is 6. And then to get the volume of the whole thing is the base times the height. 6 times 2 is 12. And they said these were centimeters, so it's cubic centimeters. Okay, here's the cylinder. The radius is 8, the height is 6. The volume is base times height. The area of the base, since it's a circle, is pi r squared. pi 8 squared, 64 pi. Now I can put that in my volume formula, which is base times height. 64 pi times the height, which is 6, is 384 pi, which is really considered the more correct answer because it's not rounded. But nobody knows what that is. So put it in your calculator and you can see that it's about 1,206.37 cubic units. Okay, now what about if it's a cube? We did a prism, a cylinder, and now a cube. This time they told us the volume. They didn't tell us the side, and we have to figure out what the side is. We know the volume is length times width times height, which is x times x times x, which is x cubed. So 100 equals x cubed. Why is x not alone? It's being cubed. What's the opposite of cubing? We don't know that. Well, today's the day we get to learn it. And the opposite of cubing something is to take the cubed root. So here's an example. See how normally we just have that and it's the square root. Well, if it's anything else, it gets a little number right there. And this time we're doing the cubed root. It could be anything. You could take the 4th root, the 5th root, etc. And when you get to Algebra 2, you're going to learn about even fractions. Okay, we're not there yet. That's next year. All right, so let's give an example. 27 is made out of 3 times 9, and 9 is made out of 3 times 3. They're in Arkham Asylum for the criminally insane, and this time one lives and gets out of jail, and he kills both of his siblings. So the answer to the cube root of 27 is 3. 2 go away because it has to be triplets. If it was 4, they'd need to be quads. Okay, so here's our cube. How we take the cube root of 100, because that's what we need to do now, is take the cubed root of both sides, is go to your button on your calculator that says math, which I call the ironic button because aren't they all math? Yes. But go to math and then go down to number 4, and it has the symbol cubed root with nothing there. And you pick it out. And when you do that, it'll pop up on the screen, the regular math screen of your calculator, and you fill in 100 and then hit enter, and it will tell you the answer, which is 4.64. There's another way to do it, because I already told you can do more than cube root. What about if it's to the 4th power? There's another button. If you go down, same thing, do the math, well, let me explain it to you first. Okay. There is another button under math where it's x square root, meaning you can put anything. We're going to use that one this time. But if you do the x one, you have to put in which root you want before you hit the math button. So I want you to do it again. I want you to do it with the cubed root thing on your calculator, and now I want you to do it again where you can do any root. So do it one more time, and you start by putting 3 on your regular screen. Then hit math, then go down to 5, and it'll have x blank radical. Select it, and because you put this 3 there, when it comes up on your calculator screen, it'll be there. You put 100, hit enter, and it should give you the answer. All right, everybody get good at that. You're going to use it a lot in Algebra 2. All right, what about the cylinder? Okay, we're told it's volume. We know the volume of a cylinder is base times height. Because it's round, we know base is pi r squared. But r, we don't know what it is. So we fill it into our formula. The volume equals pi r squared times the height 12. And we just start solving for x. Why is x not alone? It's being multiplied by a 12 and a pi. So I divide both sides by 12 and pi, and it's squared, so I square root both sides. You can put all this in your calculator at once, and your answer should be about 11. The last problem in your book is about cement blocks, and boy, that problem gave me fits. Because it says that this block ends up weighing 58 pounds, and I thought, there is no way. I have grabbed these things with one hand and tossed them before, and I cannot do that with 58 pounds. I work out, and I have a little bitty muscle, but it is not big enough to toss 58 pound cement blocks willy-nilly. The point of the problem is, if you were getting the volume of this, you'd do the whole thing, then you'd get the volume of the cutouts, and subtract it, and you could get the volume of the cement block. So look at it. But anyway, I went to the Home Depot website and I found that they weigh 36 pounds each. That is much more believable. So their block, who knows where they got their block, but they didn't buy it at Home Depot, because at Home Depot they're only 36 pounds, and I can do that. I have unusually strong hands, so I could pick that up and toss it with one hand, but not 58. All right, study the examples in your book, come back, and we'll learn more geometry. Math is great.